Well, hello and welcome to this afternoon's Forum 360, the panel here at AIAA SciTech. Disruptive technologies shaping the future of flight. So, well, I guess most of you, probably like me, probably arrived by air here over the last few days, flying through carefully controlled airspace in a sort of state-of-the-art Airbus or Boeing or Embraer airliner, before jumping in a taxi or an Uber and getting to the hotel. Well, that's all very well, isn't it? I mean, that's what we all expect. It's what we're used to. Your journey was safe, thanks to people like these people on the panel here, and notwithstanding any minor disruptions caused by weather, or if you were scheduled, unfortunately, on a MAX 9, some other issue. But you got here on time and in relative comfort. So that's great. It's the status quo. It's what we've come to expect. But, while aviation as a whole, particularly the commercial aviation industry, has made amazing strides in improving efficiency with the fuel required to fly a passenger per kilometer reducing by around 1.5% per year on a pretty steady basis. We know that much more, in fact, is needed, particularly if we're going to achieve these industry-wide targets of net zero by 2050. That's a massive target, and the clock is ticking. So, the fundamental elements of the sector, the fuel, the aircraft type, underslung podded engines, gas turbine engines, and even the way they're flown and operated and controlled in the national airspace or international airspace, nothing really that much has changed fundamentally over the past 40 to 50 years. So we're on the brink of this huge change. And, it's probably the biggest period of change in the industry since the advent of the jet engine, let's be honest. And it's a sort of a mountain, really, that's sort of appearing out of the gloom right ahead of us, and we've got to climb it. So at some point, some of these sort of disruptive technologies that we mention in this panel here will likely change the shape of the future of flight. And we've got an impressive lineup here of panelists who are going to help us gaze a little bit into the crystal ball. So in the theme of this year's SciTech, the outside-in sort of perspective, expanding the boundaries, I think we'll we'll talk as the panelists here about what are the key challenges of actually helping us achieve these amazing targets and reaching net zero by 2050 as an example, by reaching out and going beyond the boundaries. So without much further ado, what we're going to do here is I'm just basically going to quickly introduce each panelist, who will then give a little, their vision really, if you like. We'll go right across, and then we'll enter into Q&A. So I hope you've got loads and loads of really great questions for us. So we'll start with Paul here on my left. Paul McDuffee, he's the Senior Principal of Aerospace Integration at Supernal, and he's going to give us a little view on the burgeoning world of AAM, urban air mobility. So Paul, over to you.
Thanks, Guy. I really do appreciate it. As you said, I'm Paul McDuffie. I've been around a long time, as indicated by my hair color. I currently work for Supernal. If you haven't heard of Supernal, that's understandable. We are a subsidiary of the Hyundai Motor Group, who is kind of our guiding star and our major investor. Our principal role is to develop an air mobility vehicle. The company has been in existence now for roughly 4 years. I've been with them since the very, very early days. It's ironic that today at CES out in Las Vegas, we are actually rolling out the prototype version of our vehicle for public display. So kind of ironic that I'm here talking to all of you. I've been an aviation guy for the last 52 years. Prior to joining Supernal, I was with Boeing and in situ, working on the Scan Eagle aircraft. I was vice president of flight operations and training for in situ. Prior to that, it was 30 years with Embry-Riddle Aeronautical University, where I ran all the aviation programs for a couple of decades. This has been a real transition for me, obviously, to move from a traditional manned aviation world to where we are today. You know, as Guy was saying, this is certainly disruptive, and it's been a real interesting ride to take an automobile company and turn them into an aerospace company. There's a lot of misunderstandings and I won't say lack of appreciation, but certainly not an awareness of just exactly what it takes to be an effective aerospace company in this day and age. We're doing a lot of things to shape solutions to allow us to move from the prototype stage to an operational perspective. There are three kind of guiding tenets that we're looking at in all of this. Number one is do it safely. We certainly don't want to do anything that compromises the world-renowned safety record of aviation. That's something that we can't destroy or disrupt in any way. We want to be cognizant of stakeholders. I mean, there's an awful lot of current entrants that fly in the airspace that we will share with them. We don't want to be disruptive to not only legacy aviators, but the air traffic control community. It's very critical that we keep that in mind as we march toward the solution set. Finally, we're going to try as best we can to operate within the current regulatory and procedural framework. Regulatory change takes a long time. It isn't unusual to make a rule change that will govern our operations down the road. Might take 10 or more years to affect that change. So we're going to do whatever we can to operate within the current structure as best we can so that we can get to a point within a reasonable amount of time where these vehicles can actually enter into service. So we'll go into more detail in that, I'm sure, as the afternoon progresses. But again, appreciate being here, Guy, and turn it on.
Yeah. Well, yeah, and thanks, Paul. That's the whole point, really, isn't it? The fact when you're looking at disruption for the next few decades, the next 3 decades, say, where Paul's area is in urban air mobility or advanced air mobility, the eVTOL, the age of the eVTOL it's coming, and how big it's going to be, we really don't know yet. But it's a sort of disruption fueled really by propulsive efficiency changes or electrical propulsion, hydrogen, hybrid electric propulsion, ways that really open up the aperture in ways that were never possible before for aerospace. I certainly, having arrived at Orlando Airport on Sunday night, really wish the eVTOLs were already here. I'd have dearly loved to have got on one to come downtown. I took an hour to get from Charlotte to Orlando, and then it took an hour to get from my plane to the hotel. It just doesn't seem right. So anyway, moving on to Sue. Sue Partridge is head of Wings of Tomorrow program at Airbus. A truly, a really amazing program. I can't wait to hear what she's got to say. So Sue, please, next. Thank you.
So thanks, Guy. It's great to be here and have the chance to speak to you all. As you can tell from my accent, I'm based in the UK, and the UK is the home of wings for Airbus. So we'll move off this slide quite quickly in just a moment, because I think this photo makes me look slightly crazy, so apologies for that, everybody. But I've spent my career since I started as an apprentice, nearly 35 years ago, an engineering apprentice, working predominantly on the wings of all of our major Airbus programs. And all of those wings are flying today. These stats that you see on this slide in front of you are the 2019 ATAG statistics about air traffic. And of course, we've recovered to similar levels now. 4.5 billion passengers flew in 2019 across 48,000 routes. So aviation really is, as the slide says, an irreplaceable force. People want to keep flying, and we want people to keep flying, of course. aviation and flying does unite the world, and it is a force for good. It also, of course, drives economies globally, and we know the power of that. But, of course, in my career, I've never seen a situation like we have today, where we have an existential threat to our future industry, and that is about sustainability. And it's really interesting, having worked in the industry, you know, for all of my career, to kind of come to conferences like this, where everybody really is united around a common goal, and that's about decarbonizing flight so that we can keep flying. And on the right-hand side of this slide, you know, this is the challenge we face. Today, traffic grows year on year and continues to grow. And by 2050, the traffic we have today will have grown significantly. But the challenge is, by 2050 also, that we've all signed up to, and that we all feel passionately about, to achieve net zero for aviation. I'm proud to work for Airbus, where our purpose is pioneering sustainable aviation. And that's a purpose that we actually came out and started to talk about right in the middle of the COVID pandemic, where we stepped forward and we thought about the future. And I'm fortunate in that my role is really at the heart of this purpose we have, that's pioneering sustainable aviation. And so just briefly to introduce the Wing of Tomorrow program that I lead. So we launched the program 6 years ago. When we take the step of launching our next generation single-aisle aircraft in the future to replace the current A320 family, we will need to be ready. You can see from this picture, which is our wing factory in the UK in Broughton, that this is every day. The wings flow through that factory and out of the door at very high production rates. So Wing of Tomorrow is there to prepare the ground for the next generation of aircraft. And of course, the next generation of aircraft have to make a huge contribution, that technology change towards the decarbonisation target. The wing, because of its ability to influence the fuel efficiency of the aircraft, will make probably as much of a contribution to decarbonisation as the next generation of engines. So my role is to work with the team across Airbus and across all of our partners to prepare the technologies that we will need for this future generation, performance-driven, high-span composite wing. And with that, not only does it need to be a very high-performing wing, but we will need to be able to make that at a high production rate to get that into service, and of course at a sustainable cost, in order that we have a business and that the airlines can afford to buy those aircraft. So Wing of Tomorrow program is about bringing together more than 100 disruptive technologies across more than 40 partners globally, and really energizing that whole ecosystem around this future vision of 2050 net zero aviation. And that's really what the program is all about.
Thanks, Sue. That's astonishing, actually, when you think about, you know, where where the rubber meets the road, essentially, in terms of the disruption, where you're going to make the most impact. And that is such a key part of it, isn't it? Sort of like the aerodynamics and the efficiency of that, as well as making it and flying it. So, yes. So now moving on to our next panelist. We've really heard about the advances in, or we will be hearing more about the impact of the advances of urban air mobility, and now with Sue, we're looking at the big airframers. Now we move on to Dr. Jeffery Schroeder, who's really if you've got here safely and flown through the US airspace, it's down to Jeff. But he's the Chief Scientific and Technical Advisor for Flight Simulation Systems at the FAA. And Jeff, can I ask you to make you come?
Okay, thanks for having me. My name's Jeff Schroeder, so I'm about to start my 15th year in the FAA. And the two best parts of working for the FAA are, one, you get blamed for not letting the disruptive technologies get certified fast enough. And then two, you get blamed when something goes wrong. So it's kind of a no-win scenario. But I'm going to, all this talk about disruption disrupts me, so as a regulator, so I'm I'm going to put my first slide here in a high school debate format, and you can ask yourself whether or not you agree or disagree with my resolution. So I'm going to look at the far end, commercial transports, which, you know, for catastrophic failures, we need to make sure that those don't happen unless it's extremely improbable, where that's defined as really 1 in a billion. And I'm not sure we accept 1 in a billion anymore, to be quite frank, because look what's making the news now. That plug shouldn't have come out, and it's designed to be extremely improbable. We didn't have a serious injury, didn't have a fatality. It's classified still as an accident. I don't want to make light of it, but look at, it's the headline, right? So it grabs everybody's attention, unlike some other modes of transportation or unlike some other safety critical technologies. So for those instances, for extremely improbable malfunctions, I think disruptive technologies will enter aviation in an evolutionary rather than a revolutionary way. And some people might say that's obvious. I think your belief in this statement is probably correlated with age and experience. If you've made a lot of mistakes and you're older, this probably makes sense to you. But I can tell you we have applicants that come to the FAA that don't believe in this statement, that really want to push things faster than many of us are comfortable doing. And so why is this the case? Why would it be revolutionary rather than evolutionary? Well, I think when the safety bar is high, analysis and testing, which is really how we try to prove these systems are safe, that alone has a pretty poor track record. It has some successes, but overall I think it has a poor track record. Why? Because often the testing just isn't comprehensive. We didn't look at that case. Sometimes the testing's flawed. We looked at operations that really were not representative of the operational environment. And from my perspective, those two are the easiest of the three that I have. The really hard one is that the assumptions may be wrong and not challenged. I lost a year of my life working on trying to get the MAX back to flight. And that was really all about, in my opinion, and others that I've talked to, about a failed assumption combined with expectation bias. The belief was that failure would present itself to the crew in a way that was very similar to how they had trained handlings very similar for the failures. And personally, I could see myself working for the Boeing company and signing off on the logic that went down that path to approve it. I can totally see kind of how it happened. And it was just a flawed assumption, but I can understand how they made the assumption. And so, you know, that gadfly in the back of the room, you know, you've worked out your problem and you've proved what you want to prove, but there's this annoying person in the back of the room challenging your assumption. Well, you should listen to that gadfly, because it's really hard to challenge assumptions, and we're just not very good at it. And so some simple examples, if I look kind of historically in commercial aviation of what disruptive technologies are, they've all pretty much been evolutionary. Now, some of these don't make my case that strongly. Fly-by-wire, we had mechanical backups in various forms for many years, or we had very simple reversion modes. And envelope protection, when fly-by-wire came in, was nowhere near designed to be extremely improbable in their failure. Composite materials, we started in non-critical components before we advanced. Jet engines, well, Common at least had 4 of them. And a person could make the argument that if you lose all 4, it's not necessarily a catastrophe. Glass cockpits, those started still with steam gauge backups. GPS, we had other navigation sources. Supersonic travel, that was probably pretty, maybe revolutionary. I mean, it started with military, obviously, first. So that case, darn it, doesn't really kind of like support what I resolved. But they were fairly limited, maybe 1 flight a day to New York, 3 to DC. So we could kind of keep track of them. So anyway, I think that it's going to be evolutionary rather than revolutionary. But I could be wrong.
Thank you very much, Jeff. So moving on to perhaps a company that can perhaps look at all of our problems here in terms of where next for disruptive technologies. We've got Dr. Craig Wanke, who's the Chief Engineer for the Center for Integrated Transportation at the MITRE Corporation. And Craig, perhaps you can just introduce yourself.
All right, thank you. Yeah, I'm looking at this from the perspective of what we do at MITRE, which is support the FAA primarily and as a federally funded research and development center, but also as a not-for-profit in the public interest. You know, we're sort of concerned with the whole of nation sort of questions, you know, that circle around this. What I'm showing here is a picture of a future which is envisioned by an operational concept called the Infocentric National Airspace System. This is something we've worked on with others, but it's the FAA's, you know, principal sort of current organizing principle for what are things going to look like in the future. And you see a lot of things in this picture that we do today, and a number of things which are sort of in their nascent, you know, forms. Clearly, space launches have been increasing in tempo, increasing in their disruption to the other parts of the system, with folks like Supernal advocating for urban air mobility. The very beginnings of operations are starting to happen there. Small UAS, obviously, we're a little farther ahead. But all of these things are being operated essentially by exception. And I think the future, we envision that these things will operate as a seamless whole with characteristics that improve upon the current system. You know, it was noted by our moderator at the beginning that air travel hasn't changed that much in a very long time. And in fact, I would argue that pre-9/11, I think it was significantly easier in many ways, you know, to get from place to place. And I don't think from a citizen, you know, as someone who's been flying for a very long time, my flight down here was fairly smooth, but I did worry about what would happen if it were disruptive, because I don't think the current system is any more resilient, possibly less resilient, than it has been over the years. And we look at the transportation system as a whole, not just the air transportation system, but the air and ground transportation system as US critical infrastructure. It supports our economy. It has a massive impact on our ability to provide homeland security. And so the challenge is to integrate the various disruptive technologies that you see, you know, on this chart in such a way that we build a system that not only allows for these new operators and operations, but does so in a way that improves the overall stability of the system. Ideally, it improves the accessibility of the system to people, improves the resilience to the increasing number of disruptions that we're seeing, including those that climate change is producing, and ultimately, you know, provides a benefit, you know, that has those desirable, you know, economic characteristics and impact on, you know, on our security. And so, you know, the challenge for us is to take disruptive technologies, and this is kind of similar to what Jeff was saying, that come from places where go fast and break things is the norm, but to bring them into a system where that is obviously not the norm, and in fact, safety and also efficiency are incredibly highly valued. And in fact, it's almost, you know, to resolve those two things requires an enormous amount of advance that using techniques that we really fully haven't appreciated. The one thing, I called this the infocentric NAS, you know, picture, right, is that as communications technologies improve, we expect that most of these operations and the ground systems and other systems that they're dependent upon are going to be connected very fast, by very fast communications in real time. And there is a notional idea, or there's an idea that that is going to make everything work a lot better. But what we don't really fully understand, I think, is how it's going to make all of that better. And I think that that's where a lot of the sort of research opportunity is. Now, of course, one of the other disruptive technologies that's in the news a lot now is AI. And AI can play in this system in a number of interesting ways. But the ubiquitous communications is the only way we're going to get to the point where these things all play together in a logical and seamless way. And in order to do that, I think we have a lot of work to do
Right, thanks, Craig. Yeah, actually, looking at that chart makes me, I can't believe that the world that we live in and usually fly in is only the bottom sort of really quarter or third of that chart. And it really sort of emphasizes how in the future we're talking aerospace, really. We're going to make much more of the 3 dimensions that are available, and all the way from Supernal all the way to space. Talking of which, I would just like to introduce our final panelist, who, by the way, did have a disrupted journey yesterday. He was scheduled on a MAX 9 and ended up transferring to a low-cost carrier to get here by alternate means. So we've got a real-life example.
Well done.
So Mr. Shigeya Watanabe is the Associate Director General, of the Aviation Technology Directorate of JAXA, the Japan Aerospace Exploration Agency. So thank you so much for being here and coming all the way from Japan via Cleveland, Ohio.
Thank you, Guy.
Thank you.
So, good afternoon, ladies and gentlemen. I am Shigeya Watanabe from Japan Aerospace Exploration Agency, JAXA in short. So, my original background is experimental aerodynamics using advanced measurement technologies in large-scale wind tunnels. Now, I'm responsible for major R&D activities in aviation in JAXA, serving as Deputy Director General at Aviation Technology Directorate. So I'm so honored to be able to join this forum with distinguished moderator and panelists. So I'm happy if I can add some values from the point of view of Aviation Research Institute and Asian aspect. So, and maybe some of you do not know about JAXA. Briefly, I'd like to introduce JAXA first. So JAXA is a unique Japanese national R&D agency in aerospace technology. So often I introduce JAXA as a Japanese NASA in easy understanding. So the number of employees about 1,600, and the annual budget is around 1.5 billion US dollars. Like NASA, JAXA conducts both space and aviation R&Ds, but some aviation activity is much less than the space activities. Okay, let's move to the main topic of this forum. So this is a slide illustrating the promising disruptive technology for shaping future of flight. So in terms of sustainable aviation, I picked up 5 disruptive technologies: electrification, hydrogen and fuel cell, open rotor fan and boundary injection, BLI, and CO2 capturing. So since the aircraft is always dependent in the discussion of global warming, so I think if the CO2 capturing using aero engine will become the very promising breakthrough technologies, aircraft will be able to escape from the dependent position. So at present, it is just my dream with no specific ideas. For realizing supersonic flight over land, low sonic boom and laminar flow control technology will be a key technologies. And thinking about the future air mobility and safety, I picked up 3 technologies as shown in the right bottom figure. So especially autonomous flight technology integrating conventional aircraft, UAS, and AAM will be a very promising technology, which will be able to improve safety and efficiency drastically. I thought so, particularly when I heard about the terrific aircraft collision accident at the Tokyo International Airport just a week ago, which can be, so at present, the cause is not known yet, but I believe that one of the important cause will be a human factor. So using this autonomous flight technology, such kind of traffic accident will be reduced. The final category is digital transformation. So throughout the aircraft life cycle, from planning to disposal, digital transformation technology, including the MBSE, certification by analysis, CBA, and digital twins, is very crucial technology to reduce cost and time drastically. To fully utilizing the digital transformation technology, I'd like to emphasize that quantum computing and AI are very important and very fundamental technology to realize digital transformation. So in order to realize this disruptive technology, I picked up 4 key factors in technology creation phase and in technology implementation phase. So in technology creation phase, I think that the most important factor is diversity in expertise. So the disruptive technology aim a paradigm shift or new creation of new usage of aviation. So such purpose, present aviation-related expertise is not enough. So also the passion to make society and world better is always a key factor. It is true in the implementation phase as well. So in the technology implementation phase, I picked up 2 factors. First one is open innovation and close collaboration with various people and organizations such as industry, academia, research institute, government, and users. The second one is standardization and rule making, which will be definitely needed to implement new disruptive technology to society. So usually, a new technology comes first, then the standardization and rule making follows. But such situation is not effective if we want to implement disruptive technology as fast as possible. So I believe that creating new technology and developing standard and regulations must proceed in a concurrent way. This is my opening remark. Thank you.
Thank you, Shigeya. So now we're coming to the crux of the whole matter here, the question and answer session. There should be a QR code, there it is, that's on the screen to go to the question app, and you can ask or upvote a question as you see fit. But in the meantime, I was wondering if I could sort of kick off. Obviously, we've heard about, we're looking for disruptions and what's really going to change the familiar pattern that we've been used to for 40 or 50 years as we move forward. We know something dramatic is needed. And yet one of the things that always comes up is AI, as we've already kind of hinted upon. But AI doesn't necessarily have, I can already see Jeff shaking at the prospect of what AI might do. But could I ask you, who would like to comment on where you really see AI as playing a part in the disruption? Because it could have a part, but not in certain areas, particularly safety, I'm thinking, and certification. Anybody got a...
You talking to me?
I'll take a shot.
If you want to. I know Craig wants to say something.
Yeah, so in the spirit of being a technology introduced that is disruptive, but in a way that is incremental, there are things that go on in the air traffic management system that are not safety critical things, but that could benefit greatly from improved analytics, right? And so we've been doing some work at MITRE for years on trying to improve the strategic air traffic management function of the agency in concert, and this happens in collaboration with the airlines and the military and other operators in the system. And basically, in the short term, and everyone in here who's flown here has experienced the results of this process, but there's an informal process in which you look at the potential things that might happen over the next 24 hours, mostly weather, but it can be other events, and then try to determine a set of actions that we're going to take now, actions we might take in the future, such as ground delay programs and those sorts of things, to sort of maximize the use of the system and minimize the risk of extreme disruptions. The problem with this is that you're trying to make decisions based on uncertain predictions. There's a lot of uncertainty about both the sort of what the events that might occur and, of course, the response of the system to those events. And the design space is infinite. I mean, there's any number of things that you can do, right? And so we've tried various technologies over the years. And one of the things we tried to apply, starting a couple of years ago, we saw what DeepMind had done with AI to play games, right? First chess and then Go, but ultimately StarCraft. And we thought, well, StarCraft has for once, has the characteristic that here is a game that looks a little bit more like real life. There's a lot of uncertainty. In what your opponent is going to do, and you don't even know the whole map when you start, right? And so we tried to apply this, and it seemed like a logical thing. And it turns out that the real world is significantly more complicated than games. But we found that it did actually provide us a tractable thing that could be run in real time and give sort of suggested strategies to react to a particular situation that were plausible. They were innovative in the sense that sometimes they didn't do things that maybe the humans would have thought of in normal practice. And so it gives us it's given us sort of a warm feeling that there's some strong possibilities in developing what's called course of action systems. And the same kind of thing is going on in the military side, and so on. But what we also found was that it's very difficult to match the output of this technology to something that the human decision makers and operators in the system can actually accept and execute. Because there's a lot of things that the machine doesn't know, right? And it's also not clear what constitutes victory conditions and victory in traffic management, because everyone has a different objective function. In a lot of ways they agree, but there's also a number of areas in which they don't, especially when some of the operators are effectively competing, for certain resources and so on. So it's an example where I believe that eventually this will be a way to introduce AI to the system in a constructive way, but it's a lot more difficult than it appeared when I started.
Okay. This one, it seems to be a popular question coming in about, this may be more appropriate for Airbus and JAXA, really, but what new materials, sort of meta-materials, do you see as having the most disruptive impact to the aerospace industry in the next 10 to 20 years? Is that something that you're happy talking about, Sue?
I mean, I can certainly talk about the kind of materials aspects that we're exploring. I mean, in the end, from a performance point of view, we're clearly looking for reductions in weight. So, of course, composite technology is absolutely key to the next generation of aircraft. Building on the aircraft we already have in service, like the A350, which already has a large percentage of composite structure within it. The challenge for us, though, is actually composite materials can be expensive, and the processes to make large composite components can be quite difficult at high rates. So one of the key challenges is not only the material itself, but also then how can you turn that into a cost-effective, high-rate solution so that you can really get it on a future single-aisle next-generation aircraft. There's also a trade between the cost and the performance, so looking for the sweet spot between high-performing composite fibers and the cost of those, the amount of weight that can allow you to take out of the structure, and therefore saving cost on the other side of the equation. So composites itself is quite an interesting balance and pushing the boundaries of the capabilities of those materials. More on the metallic side of things, of course, we are exploring the opportunities of things like additive manufacturing. Additive manufacturing on paper is a very promising technology. There's many different aspects to that as well. The raw materials, though, are very expensive, so you have to really be able to optimize your manufacturing process so that you get a really good buy-to-fly ratio. You have as little waste as possible. And also the material itself, in order to manufacture the component is one thing, but the post-processing required then drives cost. So again, you're then trading the fact that you're having a disruptive manufacturing process for the component itself, but potentially then driving the cost back in through all the processing needed. And then there's the safety aspect as well, because you've got to have a repeatable process. You've got to know exactly what your component is made of, how it's been made, and that it meets the quality standards every single time before you put it on the aircraft. So I think, materials are a big topic for us, and they are a big topic for the next generation of aircraft. I could talk about hydrogen, because of course with hydrogen, if you're putting a hydrogen system into an aircraft, then that brings a huge set of material challenges with it, from the perspective of hydrogen embrittlement, but also from the perspective of we're going to need the hydrogen to be cryogenic, minus 250 degrees centigrade. What effect does a pipe full of hydrogen at that temperature have on the wing structure and the aircraft structure that's surrounding it? So that's another huge materials topic. So it's a really big topic, and it's a very disruptive topic at the moment, and we are doing a lot of work, and the industry is doing a lot of work on all those fronts.
Fantastic. That's the trouble with a panel like this. You could actually spend a couple of hours on each subject, couldn't you? But sadly, we don't have the time. But just switching gears to really back to your area, Paul, if we could. One of the questions we've got is, why should the cancellation of NASA's X-57 demonstrator not make me pessimistic about the future of electric aviation? And it's, I mean, I know, I've been following, if you think, well, if NASA can't do it, nobody can, sort of thing. But it's not, I know it's not really like that in this case, because I know that the NASA folks at Edwards and Armstrong were really trying to sort of blaze a trail that industry was going to take the benefit from. So it wasn't necessarily a race to the line to try and fly something. But anyway, over to you, Paul.
There's a list that hangs over my bed at night. It's called the list of things that keep me up at night. And from an operational perspective, one of the biggest challenges we have as an OEM of an electric-powered AAM vehicle is the limitations that battery technologies present. We've got an entire division who is totally focused on the creation of onboard storage of energy that will allow us to operate the vehicle with sufficient duration and with sufficient safety margins to allow the businesses to actually scale without having the ability to operate the aircraft with a certain battery reserve. It makes it extremely challenging for us to certainly meet current operational rules for flight in less than visual conditions. It does not allow us to really complete mission sets that our marketing people have examined in terms of what would be optimal for the customers. If you can't go from your departure point to a destination safely because you run out of battery energy, we're not going to be in business very long. So this is something that, as part of the overall deep dive that we're looking at operating air mobility vehicles from an operational perspective, we are really concerned about. One of the things that I've learned from working with my friends from MITRE in the past is when we look at what the current requirements are to fly an aircraft in the current airspace environment under flight conditions less than optimal, the reserve requirements are certainly unscalable. We cannot meet the regulatory requirements as they currently exist unless something changes. So we're doing a deep dive on looking at what the route structure is, considering what the limitations are relative to the battery capacity as it currently exists. And we're certainly hoping that it will improve over time, and are confident that it will. But operating, again, within the current regulatory framework, within the limits of technology, it is clearly a challenge. It's one that we're spending a lot of cycles on, and we think there's going to be solutions. Whether they'll come sooner rather than later, I can't tell you, but we're certainly aware of them and working with a number of partners, both here in the U.S. and overseas, to try to solve some of these issues going forward. But it's a great question and obviously super important to us.
Yeah, thanks, Paul. I think one of the things that, and it's interesting this, how we've seen the emergence of the AAM, UAM market really because of battery technology, that a lot of which owes its sort of origins to the automotive, at least the energy that, as it were, pun sort of intended, comes from that sector. Do you see, this is to all of the panelists, do you see other similar sort of technologies coming in from out, it's just sort of in the theme of outside in really, coming into aerospace from non-traditional aerospace sectors that we might take advantage of in the next few decades? Like that? I mean, batteries are a pretty obvious one, but are there others out there that we...
I mean, I guess on the industrial side of things, because not only do we need to innovate on the aircraft itself, but we need to also have the right industrial system in the future as well. And there is, of course, a lot of read across from other sectors in terms of the industrial system, the use of automation, the use of robotics. How do you combine a robotic industrial system with a manual process and find the right balance between the two? Because actually, often a physical human being is better than a robot, but not always. So I would say a lot of those kind of industrial technologies, there's big read across from outside our industry into our industry. And also things like materials and processing as well. We shouldn't be too proud to look outside the industry and steal the best practices from outside our industry, because if there's been the investment outside, it's there for us to take.
Right.
Again, another example for us would be hydrogen, where of course, in the space industry, hydrogen has been a fuel that's well known, but the challenges are completely different.
Yeah, and Shigeya, I know that for JAXA's perspective, you cover such a broad range of, as we saw on your slide, of aerospace research areas. Is there anything in particular where you see an outside something coming in you can take advantage of, an innovation, or is there something that you, not low-hanging fruit necessarily, but ideas for disruptive change from the outside?
Mm-hmm. Okay, thank you. Thank you for the question. So for JAXA, maybe for the all aviation sector in the world, so sustainable aviation is the most challenging and important topic, research area, I think. So as you know, the ICAO's aspirational goal of net zero carbon in 2050 is very, very high. So I think it will not be achieved only one technology, such as SAF or electrification and hydrogen. So in JAXA, we are doing the research, promising disruptive technology research for the sustainable aviation, such as electrification and the hydrogen aircraft in parallel. So in collaboration with various partners, incorporating the many types of expertise and experiences outside aviation sectors.
Right, thank you.
I got a couple, maybe.
Oh, sorry, Jeff, yeah, please.
Believe it or not, a regulator. So in the training area, the virtual technologies, people are really trying to push that. as well as in some of the technology of the training devices, like the gaming engines. So I know there was a major simulator manufacturer that's really trying to even make the visuals so much better, and that's only a result of the advances made in gaming.
Interesting, yeah. Yeah, in fact, next question is for you, one from the audience. So if countries such as China are willing to accept disruptive innovation at a faster pace in aviation than, and don't shoot the messenger, I'm only reading the question here, than the FAA, how can the US keep up as fundamental changes occur through things like electric propulsion, autonomous control, additive manufacture? Is the FAA going to abdicate innovation?
Well, back to one of my slides, I challenge your assumption. I work with China, not a whole lot, but a bit. I'm not so sure that they're willing to accept things faster than we are.
Right. Well,
So, I mean, whoever asked the question, I mean, maybe you have examples that I'm not thinking of.
I mean, it may be things like certification of EHang and, you know, the eVTOL type of, maybe, I don't know, I'm just looking at the question as well, but maybe it's those sort of areas that we're thinking of. But, I mean, the FAA's got its own, you know, clean aviation program, you know, the research work that FAA is pushing the edge in a lot of ways, certainly in terms of propulsion, which is what I follow mostly. Not only that, but obviously ATM. So I'm with you on that. But
yeah, I mean, we have some research going on. I mean, we're not a research agency. We have some research going on, and certainly in some of those areas. But you know, the way that, for the most part, and there are differences among regulators, but we do all kind of try to sync up through ICAO in many different ways, not only in certification but in operations, and so they're not really dramatic differences, I think, on the safety side. There are some, and of course, you know, since I'm an insider, I could like go on for days talking about all the little ones. But whether or not they're like major structural differences, I don't see those personally.
Yeah, I mean, obviously, the FAA's role is, you know, it has to think about safety as priority and its preeminence. And recently, because of the MAX events, it's re-baselined a lot of, it's had to go back to the basics with Boeing, for example. So I think we're in a bit of an artificial stage at the moment. You know, we're sort of looking back on history. I think it'll be an interesting period to see where this is, you know, where this has re-established a baseline. Boeing's had to renegotiate its relationship with the regulators, on both sides of the Atlantic, as a result. And I think, you know, this is partially what we're seeing. So, but I don't know whether that implies that the FAA wouldn't be the first to regulate or certify an eVTOL like an EHang with no pilot, for example, as quickly as China's done. I don't know.
That's an interesting question. I don't know.
Yeah.
You know, it's interesting you bring up the MAX because, well, I mentioned I was pretty heavily involved in that. For those of you that remember the news stories, we were the last to ground it. So in terms of being liberal versus conservative from a regulator perspective, and we took a lot of heat for that. A lot of the rest of the world grounded them first. And people were asking, why didn't we do it?
China, in fact.
Yeah, well, yes, China, as a matter of fact. So, I mean, and our answer was show us the data, right? I mean, they were kind of, I think, there might have been an emotional component to some of the others, but we didn't yet see the hard data that suggested it needed to happen.
Yeah. Well, okay. Sorry about putting you on the spot there. There's a good question here is disruptive aerospace technology research driven more by government, military, commercial, or global warming concerns? You know, where is it all coming from, this drive, really, right now? I mean, I think I know where the answer is, certainly on the commercial side, you know. It's the net zero target is out there, and that's galvanized massive amount of interest. So any thoughts from any of?
Yeah, I mean, I certainly agree with you. It's the game-changing target for us, and it's definitely the energy behind
You're right.
you know, our kind of main technology trajectory.
Right, and Craig, you're going to say?
Well, I think there's a number of pressures, largely economic ones, that are pushing sort of the current generation of these technologies. I mean, automation, why are we trying to automate things? We have personnel challenges, pilot challenges, so on, and so there's motivation for moving some of the capabilities into systems where you can do things like deliver, packages where one person can be managing a number of drones, and so on. I don't think that becomes as important a thing if we aren't having trouble with, with workforce, right? I think, and the automated driving on the ground is also generating technological pressure that we're seeing, transfer itself into the sort of aviation industry in an interesting way. Why are we trying to do some of those things on the ground? Part of it, again, is workforce. Part of it is safety. That's on the ground side, I mean, that's a major motivation to try to develop some of these automated systems. And it's also interesting to see the approach that's being taken with automated vehicles on the ground obviously isn't one we would take in the aviation industry. Yeah. On the other hand, some of the results of that work, I think, will find its way in. An example, one of the previous questions was what disruptive technologies, potentially are coming from elsewhere. Well, I think one of the things we're learning a lot about on the ground is the utility and limitations of computer vision systems, under what conditions they work and so on and so forth. And as we have a couple of companies trying to automate cargo flight, for example, and which means you need a taxi, they're learning a lot now about how that works on the surface. And coincidentally, we have challenges with safety on the surface that maybe this is a way to learn some things there that will help us out. So,
one of the questions I've got here is, it seems like it's an either or, I don't know, but generative AI, which is the sort of gorilla in the corner or whatever you say, versus high-performance additive manufacturing methods. Which one do you believe holds more weight in the innovation of the aerospace sector in the coming 10 to 30 years?
What were the two options, sorry?
Generative AI or high-performance additive manufacturing? So it seems kind of weirdly two very distinct, not necessarily relatable things, but you can see where the question is coming from. It's certainly attracted quite a lot of, it's risen up through the ranks. It's got everybody stumped on the panel.
I mean, they're two very contrasting disruptors, for sure, and both have their place. It's quite hard to say, will one be more important than the other? I mean, if I had to choose, I'd probably say generative AI, because it touches potentially every aspect of the industry, whereas, high-performance additive manufacture potentially is much more niche in terms of its application.
You're right.
That would be my view. I don't know what the other panel members think.
I mean, that's a good question. I agree. I think the generative side is probably more appropriate. AI is one of those topics from an OEM perspective that is significant for us, because our business people realize that the business case for air mobility vehicles probably won't close unless we have very high levels of automation to full autonomy. We know, Jeff, I'm sure this is one of those things to keep you up, that the term autonomy when it comes to air vehicles is, I won't say it's a bad word, but it's one that raises the little hairs on the back of your neck. Certainly a topic that was very, very important to the discussions when it came to integrating drones into the airspace. Well, the idea of having fully autonomous manned passenger-carrying air vehicles is really a goal. It's an objective of our industry. Initially, when these vehicles hit the streets in an operational perspective, over the next decade, they're going to be manned. There'll be a pilot on board. That is not the optimal situation. Everyone pretty much realizes that in order to close the business case, to make these operations truly scalable, we have to remove the pilot. So, the introduction of AI to the highest degree is certainly something that's on our radar, and we will evolve in time to that day. It's not going to be tomorrow, but clearly it's something that's going to be important to us.
Jeff, you're looking very thoughtful.
Well, I mean, before I answer which one I think has more weight, I should note that I predicted that SpaceX was going to be a flash in the pan. So I think in terms of which more weight, there's probably a weighting function in determining which has more weight there, because the first thing that came to mind is I think AI might have more impact on the design side, or maybe the preliminary design. Additive manufacturing maybe more on making money for the company.
Yeah.
It's hard to say, I bet.
It's not exactly apples and apples, is it really? So, yeah.
You know, one thing about the pilot thing, that's one of the areas that I think we're getting pushed pretty hard, that it causes some uncomfortableness. There's not only like maybe getting rid of the crew, but going from 2 crew to 1 crew. And the interesting thing about kind of analyzing the acceptability of that is we have a lot of examples about the crew, things going wrong, or the crew making mistakes. But where we have a dearth of data is when the crew made a save.
Right.
You don't hear about, we don't publish those.
When
you know?
they did their
NTSB
job.
doesn't investigate when the crew made the save. Right. So and there are a lot of them. So that's an area where we could probably do a better job of kind of.
Right. It sounds like an obvious thing in a way, doesn't it? The pilot, the crew are doing their job, but how important was it to avoid something which nobody knows would ever, you know, it's the accident that nobody ever knows about, sort of thing. So I guess the other area really that sort of seems to be of interest to the audience here is, what are the ways to balance open innovation and security concerns with the development of disruptive technologies? Because this strays into, you know, particularly I would imagine UAM or single pilot operation. I mean, there's all sorts of in the airspace. Do you have any thoughts on that? Anyone?
You looking at me?
You will.
Yeah, it's again, one of those topics. There's a group, the TSA is actually formed, looking at that security piece for AAM operations. You know, there's been some surveys done, you know, basically surveying the public to find out, you know, how comfortable would you be riding in one of these small electric-powered vertical takeoff and landing aircraft with 3 strangers on board. You know, and there's a level of concern about that. Where these aircraft ultimately fly, you know, they're going to be part of the entire trip scheme for a passenger leaving from a downtown location to a major airport and then getting on board a commercial airliner somewhere. You know, where is the TSA security piece integrated into that at the vertiport or at the local level? Yeah, again, it's one of those many issues that, again, from a public perspective, are of great concern.
Yeah, and Craig.
And also, if we're going to start connecting all of these systems together in order to generate, you know, the kinds of synergies that we need in order to make, you know, to support the business model you're talking about, right? You know, so it doesn't help to take something like the aircraft that you guys are proposing and building, and take it from point to point and then not be able to meet up with the next leg of whatever it is that you're meeting up with, right? And so you're going to be connecting to ground transportation, you're going to be connecting to other air transportation. These systems are going to be connected together, and we're generating a very large cyber attack surface that I don't think we're fully capable of securing at the moment. You know, right now, the Biden administration is putting in rules for things like rail and other critical infrastructure, you know, and we're going to have to scale those up to cases where now we're connecting modes of transportation in such a way that, you know, to support open innovation, right? You want to make that data available. You want to give people the opportunity to design systems that do good things, but that's going to be a constraint.
And at the risk of feeling like I'm picking on you, Jeff, I promise you I'm not. One of the questions that seems to have been risen through the ranks is, and it kind of really speaks to what we were discussing a few minutes ago, aircraft like the Boeing 777X aren't particularly disruptive or innovative, yet take much longer to certify than older aircraft. Why?
Because they work?
I mean, that's...
Yeah. I don't know. I mean, there's been alternatives out there in terms of the airplane looking a lot different, and you can speak a lot more on this than me. But I mean, there are at times funny things that kind of prevent it. Years ago, I used to work on a oblique wing, which was a nice kind of Mach 1.4 kind of thing. It wasn't like Mach 2 plus. But the big thing that nailed it was evacuation requirements.
Was the what, sorry?
Evacuation requirements.
Oh, yeah, okay.
Getting everybody out of the airplane.
Yeah.
And so there are a lot of these kind of gotchas that, you know, maybe some of the gotchas need to be re-examined. It's hard to say, but yeah, sometimes there are, and maybe it's like a structural problem where these things arose as a result of today's configurations. I don't know, but I know that sometimes that's gotten in the way.
Yeah, well, and I think personally, I'd argue that there is a lot of innovation with the way that, with the 777X, for example, I mean, the folding wingtips for long-range cruise, the ultra-high bypass, you know, GE9X, which really do push the state of the art to a new level. It's the first Boeing-built large all-composite wing. You know, that's all the 787 wings are done in Japan, for example. So I mean, there's a lot of I think there's a lot of work gone into it, and I think it's another victim of you know, of the timing. It's just a weird period that we're going through of reestablishing certification baseline. Yeah. So it's just happened to be in that window.
To the FAA's credit, I mean, there has been a real shift in thinking in terms of the process for certifying an aircraft. They've moved from, or are moving from, a very prescriptive approach to it to a performance-based approach to it, which should begin streamlining things for us, you know, going forward.
Yeah, that's actually a very good point. How would breakthroughs in radar and comms technology affect the air transport industry, for good or bad? Do you think there are some additional breakthroughs coming in that? I'm thinking maybe more space-based communications and radar systems interacting. Maybe this is something that maybe JAXA or the MITRE might be able to contribute to.
So, sorry, I couldn't hear your question. Yes.
The possibility that future advancements in air transport might be enabled by improvements in in radar and communications systems, maybe from space.
Sorry,
It's
I hear you.
Well, it's a difficult acoustic up here.
Sorry
isn't it,
about
actually?
that. Yeah.
How about you, Craig? Would you have any thoughts on that?
Well, I mean, one of the things that's, you know, that's coming along, obviously, is we now have LEO constellations of, you know, that provide networking capabilities. That clearly could be a component of the solution in the future. You know, we have poor communications over the oceans. It's a way to address that sort of thing. And you're getting much faster bandwidth. Now, a current commercial flight generates on the order of 0.5 terabyte of data. Most of that data might not be relevant to air traffic management, but it's relevant to other things, you know, health of the aircraft, so on and so forth. So you can envision, and you know, as part of this communications environment, that this is a component of a more integrated and, you know, more resilient system. Exactly how, I think, remains to be seen. But other than providing passengers streaming, you know, entertainment, which of course everyone wants, right?
Right. And here's another one to do with more back to the AAM business. Thus far, battery electric aircraft have not been considered as a feasible technology for future passenger transport aircraft. What, according to the panelists, would be the minimum aircraft spec in terms of size of passengers, range and battery energy density before we consider this a viable technology? I mean, I'm thinking like is it ES30 or the one that United has ordered, for example, the Swedish development? I mean, that's a pretty big electric airplane, 30 plus passengers. Any thoughts on, because this is, you know, again, a huge part of the disruption, isn't it, going forward over the next few decades? How big can electric, particularly these ones, get? I mean, my thought is that hybrid's going to be the way forward, but eventually batteries will catch up.
Yeah, I mean, certainly hybridization is a potential way to get around the constraints. I mean, the fundamental issue is going to be about how much power density you can get from future battery technology. And the other thing that's interesting about batteries is when you fly with any kind of fuel like kerosene, SAF, hydrogen, you burn the fuel while you're flying. So your plane gets lighter as you fly, and you get a huge efficiency saving just purely through that very simple effect that you're burning the fuel as you go along. With a battery, you've still got the whole battery on board when you land. And I know it's a really obvious thing to say, but actually that does drive a big difference in the trade when you're looking at power density than a fuel that you consume while you're flying. So I think the battery technology is obviously moving on very quickly, but it needs to, move on another order of magnitude. You're never going to avoid the problem I've just described. And I think you're right that we're more likely to be looking at some kind of a hybrid model on a bigger aircraft than a pure battery-powered aircraft. But I mean, who knows in 30 years when none of us are around and there's different people on these panels, what the conversation's going to be. Innovation moves on. So I would never say never, but today that's the equation we're looking at. I mean, you know much more about that than I do, but that would be my take on it from a commercial aircraft point of view.
I must admit, I mean, we used to, when I was going to SciTech and in Reno and Nevada in those days, and I don't know how many are old enough to remember those days, but it was, I mean, electric aviation wasn't really a thing. Hydrogen propulsion wasn't, except for space, these are all, have come out of nowhere really in the big scheme of things. So who knows in 10 years? In fact, one of the questions here is about, with the emphasis on sustainability, is there a role for the hybrid airship with its high efficiency and volume for fuel like liquid hydrogen? I mean, that's, airships have always been promised and never really made it, but do you think that maybe we are looking at an era where this could be a possibility?
I'm not sure I can speak to airships. They don't have wings, do they? So.
They don't. Well, maybe hybrid. I don't know. I don't know. No takers on that one? Okay, well, I do have a...
There are currently commercially developed, airships out there. There are a couple of operational concepts where it makes sense, but not obviously for the majority of aviation. It makes good sense for things like disaster recovery kinds of operations and so forth.
Yeah.
Right. And of course, it's interesting to see the variety of designs coming out, right? There is a company, and the name escapes me at the moment, at Moffett Field, right, which is building these. You saw on the JAXA slide, one of the effects of looking at hydrogen propulsion is you get very differently shaped aircraft. And I thought that was interesting, thinking about that also in the context of the panel this morning, where the question was asked, well, would you rather be cramped like this and get a 2-hour flight over the Atlantic, or take an incredibly comfortable slow flight
right, yeah.
over the Atlantic, right? And thinking back to the videos from the Hindenburg, and yeah. that era, right, which was absolute luxury, right, but very, very slow. So there's a continuum there,
Right.
Exactly which ones are economically viable, I think, remains to be seen. But
I have to say, as a poor journalist, I wouldn't ever have the option of a comfortable 10-hour flight. I'm usually at the back of the bus. So I'd like to try and get there as quickly as possible. But on the other hand, I probably couldn't afford the supersonic option either. So maybe I would have to stick with an airship. I don't know.
Yeah, I don't know.
But one of the questions we've got is for JAXA particularly. Maybe it might be difficult with the acoustics, I know, but for JAXA, how feasible is it for long-term lunar presence by 2050? And what economic benefits do you think it offers? This is basically going to the moon and the space area that we saw on your slide. Do you think a lunar presence by 2050 is potentially achievable?
question about the potential vehicle at the 2050?
2050.
Okay, so I'm not sure that I understand the questions. I think that 2050, we have a lot of technology will be realized, especially the hydrogen aircraft with battery ingestion and fuel cell technology will become the very important technology to attain the net zero carbon goal, I think. So I'm not sure I can understand. Answer the question. Okay.
Well, thank you for the stab at it.
Sorry about that.
And actually, another space-related one, Jeff. What was it about SpaceX that led you to believe that they were a flash in the pan?
Well, so I worked for NASA for 20 years, and so I thought only the government could do it safely. I thought that they would have a catastrophic accident, and then that would be the end of it. So I was wrong.
Welcome to saying.
I don't think anybody could be, would have sort of argued with you on several of those points, to be honest, especially in those early days with Falcon 1 and then, yeah, exactly. So one of the questions that's coming up as well is it takes a significant amount of time for a new aircraft becoming available, or from becoming available, until the effects are visible at a global scale. So that's a very good question, actually. You know, is 2050, those targets, is it realistic? You know, can we make as much of an impact by refleeting by that time as we think? Given the fact that, of course, the global fleet continues to grow anyway, you know, today at huge rates. It's a good question, actually. Any
You want me to
takers?
start on that?
You certainly go ahead.
Good Airbus question.
I mean, this is why it's so important that the sustainability roadmap is built up of all the things it has in it. The first one being ramping up production of our existing products, getting those into service, because an aircraft we put into service today is, you know, already 30 to 50% more efficient than one that was put into service 30 years ago and are now reaching the end of their life. So that on its own makes a contribution and makes a contribution every day. SAF, similarly, is a drop in fuel. So by the fact that aircraft can already, certainly for Airbus, our aircraft are already certified to fly on 50% SAF, and by 2030, all of our Airbus aircraft will be certified to fly on 100% SAF. So then that is constrained by the SAF production rather than the aircraft itself. Completely new technologies and completely new aircraft, of course, take not only the lead time from launch through development, test, and entry into service, but also then you've got to go through your phase of ramping up production because, you know, in your first year, you're only going to make a handful of aircraft. So it's absolutely right that, you know, that lead time is long, and the impact of those new technologies will have much more of an impact towards the end of that period between now and 2050. So we need all of it. We need the new technologies, we need SAF, we need to be ramping up production and delivering today's efficient aircraft. And we also need the other aspects around that, like the better air traffic management and managing the aircraft operations so that when you're flying it in as efficient a way as possible. That's the only way that we're going to achieve net zero by 2050 is by all of those different facets and all of them working hand in hand and coming together.
Yeah, exactly. And it's all about joined up thinking, really, isn't it? Because, you know, for example, avoiding contrail formation, you know, as just part of that, as another element. So, yeah.
Yeah, the non-CO2 effects are another whole part of that story, because it may be that, you know, the impact that contrails have, that's a very early science and there's lots of research going on. But, you know, if they're having a similar impact to CO2 in terms of global warming and in terms of being another form of a greenhouse gas, then you're then trading between potentially taking a slightly longer route and burning more fuel in order to avoid forming a contrail. And that's another trade that is needing to be worked through and understood and is another new part of the science as well.
There's a few questions actually coming up about equality, I suppose. One of them is, with increased distribution and focus on safety and efficiency, how will airspace be equitable for the airspace users? See where that one's going?
How will it be equitable in terms of how will it be affordable for individual passengers, or?
Equitable?
I don't understand the question.
Equitable. I think it means just in terms of the access to airspace for all sort of thing.
Well,
That's
yeah. No, go ahead.
Yeah, I was going to say that's the 300-pound gorilla in the room.
That was the phrase I was looking for.
Yeah, that was tough. That's really the crux of the research that we're currently doing with NASA and FAA, is to try to figure out how do we reshape air traffic management so that we don't disrupt to any significant degree, traditional legacy operations. Air mobility, the vision is that someday the sky will be darkened by, hundreds of these vehicles flying in the airspace over major metropolitan areas, substituting for, the current ground transportation infrastructure, allowing people to use them like Uber, for example, to go from point A to point B, short duration flights in all weather conditions. That obviously is going to have significant impact on how airspace is managed. So things are going to have to change. One of the earlier questions about what technologies might be, that are currently under development, might be inculcated into what we're doing. One of them is the communication protocol. Those of you who fly aircraft or are familiar with how it's done, you know that air traffic management is very dependent on voice communication. You talk to an air traffic controller, you exchange information, you're giving clearances to do things. That model probably isn't going to work when we're talking about huge volumes of activities. We're looking at, the introduction of or increased use of a thing called CPDLC, controller pilot data link communication, something that is just now beginning to emerge and become more routine. That's probably going to be fundamental to these operations. How these aircraft are actually separated in flight, what distances are they kept from other traffic and from each other? Is there a strategic management process rather than relying on an air traffic controller to separate the aircraft so there's no collision potential? Again, we could go on for hours talking about all the little nuances that are touched by this, but it's pretty clear that more research, more data has to be gathered that we can share with the regulators and kind of shape the new system, as these things become more routinely operational over the next decade and beyond.
And Craig, you were going to say?
There's another interesting opportunity from an equity standpoint, which is, we have a lot of communities in the U.S. that are underserved, for air transport, right? And we've had the essential air services, for years, but that provides a partial solution to that. One interesting disruptive technology opportunity is that regional range electric aircraft might provide an economic alternative that would bring the price down on these kinds of operations and maybe, get better connectivity to those communities. So that's one case where you can see a disruptive technology actually producing a more equitable solution.
Yeah, that's a good point actually, and sort of related to that. It mentions new transportation systems often have adverse effects for minority communities. Mm-hmm. How will urban air avoid similar problems? It's a very pointed, obviously, sort of related to sort of the last question, but...
Can I talk minority access, or?
I think it means, in terms of the communities that are often end up living right, cheek by jowl with major airports, really.
Yeah, again, I can speak for our own company. I mean, that's something that our airports team looks at. What communities do we want to serve? The air mobility is not going to thrive unless it's available to everyone. And, we're obviously cognizant of that. The actual construct of the business relies on, routine access to the airspace, high volume of flight, efficient operations of the vehicle, low operating cost, et cetera. Our targets are that the passenger fare on one of these vehicles would be very equivalent to what you'd pay for Uber Black or something along those lines, which I think is may not be the optimal, but it's kind of it's a nice target to look at. So it's a challenge, but we don't think this business is going to make it unless we can be accessible, routinely accessible to anyone who wants to take advantage of the service.
Right, and I've got two kind of final questions here, which I think ought to be addressed because they've gradually risen up through the ranks. One of them is, why is it so hard to gauge how large the market for UAM will be? Seems to be a popular question.
Why is it so hard to what?
Gauge how big the UAM market will be. Kind of, because you do see vastly different estimates, don't you? The sky is going to be black with eVTOLs, or it's just going to be a boutique service available from airport to downtown in 5 cities, sort of thing. Any thoughts? I mean, I think it's going to be much bigger than people think eventually, but not for a while.
Well, to recover the investment that's being put into it, it's going to take pretty significant volumes of operations. So I think, we're taking a very high, very positive view of the future. It's not something that's going to happen in the next decade. You've heard the 2050 number. That's probably a number that's shared by certainly many of our competitors as a target where these operations have scaled and are affordable and routine. And I think that's a fair number, but we'll see.
Okay. And then I suppose probably the last question here is, and this is back to certification again. While agreeing with your resolution, certification cycle times are at historic highs. What can the FAA do to bring certification times down while maintaining the safety of the process?
You tell me. It's a hard problem. I mean, certainly after, there used to be a lot of delegation to kind of help us, and that became fairly unpopular after the MAX accidents, depending on how you define delegation.
Yeah.
I don't know. Those are conflicting goals.
Right.
And I don't know. We've tried. One thing that's kind of very popular right now that's been alluded to by JAXA was the certification by analysis. There's a lot of parts of that depending upon what we're talking about that we're uncomfortable with, but some we are comfortable with, and so that speeds things along certainly. But with the scrutiny of the recent years, it's really hard for us to kind of take anything but a very conservative approach to certifying a new vehicle.
Yeah, and I think we've sort of clearly seen that we are on the verge of major changes and the introduction of a vast array, really, of new technologies which will disrupt the industry. And as part of that, we're stepping off into a new era with certification too, because that has changed and it's going to continue to change, isn't it? Evolving really to meet these new technologies as well as they sweep through the industry. But I'd just like to close really by thanking our panelists I think they've done a marvelous job across a huge range of questions and technology areas. And thank you to all of you from traveling from so far away as well, against all the odds. So I would just like to say thanks again and appreciate you all being here. And on behalf of the AIAA, thank you for participating in SciTech.
Do you wake up on your own? I wonder where you are.